Hello. This is a little project that I've been working on. Hope you both enjoy it and learn from it. Before I can actually get into the build box and stuff, we gotta cover a few basics of air pressure. Let's go with the first question, which I feel is decently obvious. What is air pressure? Air has mass and weight. That weight is pushing you from all sides because of gravity, and I'll explain more in the next question. Next question. Then why can't we feel that weight from the air pressure? Well, I personally gonna describe it in this form. I could describe it maybe in slightly different ways, but this is the way I'm going with. But basically, we have pressure on the inside of us pushing against the air pressure, so we don't really feel it because they're just kind of equaling each other out. Next question. Why are we covering these questions? Because what is this build box about? It's about air pressure. So I really need you to understand the basics of air pressure before we actually get into the build box. Okay. Thank you. So, let's get into the next step. So, let's see. How does the build box initially work with the rockets going outwards? So, first we imagine all these little dots are air. So, we have that. But we also have some air in here. And even some air in here. So when we squish down on this, like that, all that air will try and go this way because it doesn't have enough space. So it'll go down this way and up the tube, but then this is in the way. So, and this is really light, it'll just push it out. We also have a rubber band under here, causing this to spin in this direction. But this ratchet is stopping it from spinning in this direction as long as this is in the way. So since that is in the way, it can't spin. But it can actually spin this direction because the ratchet isn't actively stopping it because it's flexible. But as soon as you remove this rocket by the rocket going upwards, this isn't no longer being stopped by the ratchet, so it'll just spin. So that's pretty simple, right? Yeah. Okay, so that's it for this particular portion. I would say, if I didn't want to talk about kinetic energy and potential energy. Basically, we have we're gonna have a big ramp like this. We have a flat area here. And let's just have a little skateboard here. We have our skateboard. So this skateboard can go down this way. It has potential energy. It has the potential to have energy to be going down. But as soon as it starts going down, it'll lose potential energy, and that potential energy will be converted into kinetic energy. Kinetic energy is just a way of saying that it's using that energy for something. For example, in this it's moving. That, and we could also cover thermal energy, but that's not really that important for this particular case, because it's not that really impactful on what we're doing, so I'm not going to cover it. If you do want more stuff and coverage on thermal energy, I'll probably cover that eventually at some other point, but yeah, so I just want to cover potential kinetic energy. So yeah, that's it for potential and kinetic energy. Let's talk about some history of air pressure and how it works. let's first cover, people originally thought it was impossible to have a vacuum. I mean, it makes sense. Something has to be filling that space. But it was actually proved wrong when Italian miners found out their pumps could only suck up to 10.3 meters. And yeah, so it doesn't really matter how much it is in feet or anything like that. But it just matters about that, because eventually another scientist did this experiment with water. It found out the water would go down, but only to a certain point. And that certain point was 10.3 meters. Again, doesn't really matter that it's specifically 10.3 meters. It's just what it was. But he found that there was actually nothing within that space above the water. So that's just interesting. And that is also really important on how modern day barometers work, especially the mercury barometers, which were outcast in 2008 because of the toxicity of mercury. But basically the way it worked is, since you had that empty space, as air pressure rose in the outside world, it'll push water or mercury or whatever back down and back up the tube. But as soon as the air pressure lowers in the outside world, the height of the water or mercury in the tube will actually lower, because there's not much weight on the outside portion. Let's draw a quick diagram of what that would look like. So first, we have this. But we also have a little container here. Basically, there will be liquid here, and usually around about to this point. But as soon as there's more pressure coming in from the outside, the liquid will go higher. But as soon as the air pressure outside lowers, there's less weight up here. This water level here will actually lower because there's less weight over here. But when the air pressure raises, there's more weight down here, causing this to actually raise. So yeah, that's just pretty simple explanations of what I am saying of how this build box works. So hope you enjoyed it, and thank you for watching.